Welcome to Dimensional Analysis 3. In this video, we'll take a short little review quiz on a multitude of topics that are needed in order to successfully complete dimensional analysis problems and do one additional practice problem. So again, be sure to pause the video if you want. It's not a time test, so you can stop after each question and think about your responses before you watch the video and see what the answer is. And then again, for that last problem, you might want to have something to write out and your calculator handy. So, which of these, of our 5 choices, is equivalent to 9.00 times 10 to the minus 3? In this case, there is only one answer. And the answer is D in this case. Right? So you had to be able to understand what scientific notation is representing, as well as understand how significant figures are shown in scientific notation. So remember, all of the significant digits are in the number in front of the power of 10. Right? The power of 10 just tells us where we're going to put that decimal place. And since it is a negative power of 10, that means we're going to have a number that's smaller than 1. So those zeros there after the 9.00, because of the decimal point, are significant. So our answer, the correct answer, should be a small number with 3 significant digits. So that is 0.00900, choice D. All right, number 2. Which of these measurements has 4 significant figures? 4 and only 4. And there may be more than one correct answer here. So think about all of the choices that may have 4 significant figures. Okay, so our first 2 choices there, A and B, both have 4 significant digits. Right? Our first choice there, A, has 4 significant digits because of that decimal point. That makes all of the zeros at the end, whether they're before the decimal point or after them, it makes them all significant. So the 9 and the 3 zeros are all significant in choice A. In choice B, the zeros that are trapped or in between the 9 and the 5 are significant by definition, and our 0 at the end is not significant since there is no decimal point. So we do only have 4 significant digits. The 9, the 2 zeros that are trapped, and the 5. Okay? All of those other ones do not have 4 significant figures. Choice C, remember again, those zeros at the beginning are never significant. The 0 at the end is significant because of that decimal point, but that only gives us 3 significant figures. Our 1.0090 liters, choice D, has 5 significant figures. Those zeros, again, that are trapped are certainly significant, and our 0 at the end is significant because there is a decimal point there. So all 5 digits that we can see are significant. And in choice E, again, those leading zeros, those zeros at the front end, even if there's a decimal point, it doesn't matter. The zeros at the leading end, at the front end of the number, are not significant. So that last choice really only has 1 significant figure. All right, now to think about our units and our prefixes and what that means about the size of things. So which of these are true statements? Again, there may be more than one right answer. So pause the video and think about those. There's a lot to sort through. All right, lots of them were true. Actually, all of them except for the first statement are true. So that first statement looks close to what we think about for a kilogram, but a kilogram is 10 to the positive 3 grams. And then all of the other statements are true. A millisecond is a bigger unit than a microsecond. Milli means 10 to the minus 3, and micro means 10 to the minus 6. C looks very is true there. It's the definition of what a centimeter is. So 1 centimeter is 10 to the minus 2. The centi prefix means 10 to the minus 2. So 1 centimeter, 10 to the minus 2 meters. A milliliter, again, a milli is a prefix that means 10 to the minus 3. It means a smaller amount of the whole unit. So a milliliter is smaller than a liter. And 1 mega degree Celsius, mega means a million. It means times 10 to the 6th. So a mega degree Celsius is 10 to the 6th, or a million degrees Celsius. So those are all true, again, from knowing what our prefixes mean and from knowing their relative sizes. Okay, here's one that's going to require a little tiny calculation. So on planet Wilmanium, exactly, that means by definition, 3.55 yurtles are equivalent to 0.85 turtles. So here's your question. Given that information, if you earn 25.0 turtles on planet Wilmanium, how many yurtles have you earned? Okay, the answer is E. For this one, you had to do a small dimensional analysis problem. And again, you can use the same process, even though the units are nonsense units, units that are just made up. It works the same way. You have a conversion between yurtles and turtles. Those are two different units. Again, we don't know what they are. They're just made up, but we know what the proportion is between them, and we know what it is based on a definition. That's what that word exactly means. It's from a definition. There's no uncertainty there. So when we do our calculation, we should have 3 significant figures based on the value we started with, since our conversion factor is an exact number. So our answer is for this one 104 yurtles. All right, here's one you can do without a calculation. This is our last one. How many seconds are in a year? The answer is 12. January 2nd, February 2nd, March 2nd. All right, that's just being silly. We could actually solve this problem for real. I know many of you have already picked up your calculator and were furiously calculating when we got silly. So let's actually do that problem. Let's convert from 1 year, that's a time unit, into seconds, a different time unit. Right? And we should, of course, expect our answer to be large. We know there's a lot of seconds, they're not very long, in a year, which is a much longer time frame. Okay? So our plan is to go from years, right, to days, to hours, to minutes, to seconds. Right? Those are the typical relationships we know. If you know already how many, say, hours are in a year, you might be able to combine a few steps here or make it shorter. But this is probably a typical plan for most of us. So again, we'll use our same pattern that we had before. Let's write down what those relationships, what those conversions are. So 1 year, we'll assume it's not a leap year, 365 days. 1 day, 24 hours. 1 hour is 60 minutes, and 1 minute is 60 seconds. All right, so we can, again, same way we've been with all of our other dimensional analysis problems, we're going to let the dimensions, let the units do the work and help us to arrange all of our conversion factors, we have 4 of them, properly, so that the units of years cancel and the units of days cancel, hours cancel, and minutes cancel, and we're left with just the units of seconds. Now we can pick up our calculator and come up with 31,536,000 seconds. Okay, we'll take a look at significant figures. Right? 1 year is not exactly 365 days. That is we were assuming it was not a leap year. So that really does have just 3 significant figures. All of the other units are definitions. So our answer will report more properly as 31,500,000 seconds. You could, of course, have chosen to put it into scientific notation. That is your prerogative, unless you're specifically told otherwise. All right, well, thank you for joining me for Dimensional Analysis 3. We'll see you soon.